Thank you for those presentations. Really cool, I think, it sums up the whole thing. My question is that NASA has generated a number of innovations that have trickled down into general community. Formula One has generated innovations that all car drivers benefit from. What do you think are the innovations that your projects in terms of training, equipment, or awareness are going to bring that will affect the rest of us and the rest of the community?
Go first.
Yeah. From our point of view of Deep, we very much want that to exactly what we achieve. Start with equipment. The aim is to use our technology, our research and innovation team, the manufacturers we're currently working with on our own manufacturing department to basically take the equipment that's commonly used now, commercial, rebreather, open circuit, and improve it with the sole goal of being safety. So look at what's available, make it better. And it's a really big part of what we're doing, because really 50% of what we're doing is not the habitat, it's the ability to get outside of it and actually touch that frontier. So equipment-wise, definitely. And same from a point of view of physiology. We want to work with the best in the world in research and give them the opportunity to learn more, because there's so much stuff that isn't known because there's not the funding or the personnel to do the research that there's the people with the capability to do. We want to try and add to that.
Fabien, do you want to?
Sure. Well, yeah, Brian, you can talk on the science aspect. In terms of technologies, I believe that the goal is to offer a platform to continually develop technologies, and we're fully recognizant of the fact that we ourselves are not experts in everything, and therefore the platform will be offered to some of our tenants to be able to develop future technologies to perfect them. Now, that said, we're based on some tried and true technologies that have advancements in them for redundancies, and I concur, safety is absolutely paramount. And as much as I would love to see human beings colonize different parts of the ocean permanently underwater, the reality is that there are physiological and psychological parameters that are not necessarily conducive to certain aspects of individuals for long-term deployment or desires for that matter. The examples that I can point to, and I'll start by saying something my grandfather used to say to really tick off the producers in various networks is, if I knew that, I wouldn't go. And that really is the essence of ocean exploration and discovery and development, I believe, in most any discipline. If we knew what we were facing, if we knew what we were going to discover, if we knew what we were going to develop in the long term, it kind of takes away the mystery. But what I can say is the partnerships that we've had with Mission 31, for example, with the Muse, we were able to do some R&D ourselves, our team, to develop and perfect a headset that can look at circadian rhythms, et cetera, et cetera, et cetera, for the better health of the individual human being, the stress levels, all these sorts of technologies. And those findings that we were able to perfect under extreme conditions, meaning under saturation, played into the fact that that company was able to develop a commercially successful product and service, including the software, that now is integrated in things like Apple Watches and all sorts of other things. So we're blessed for that. Our partnerships with universities like MIT and engineers who have spin-offs like the Edgertronic camera, which was an experimental camera that we used underwater for our filmmaking. We custom made a housing, learned a lot about that. We were able to perfect the high-speed camera in ways that, in an extreme environment with low light, were very beneficial to that particular camera and to science. And being able to shoot 20,000 frames in a box that was originally costing filmmakers over $200,000 for that kind of equivalent power in a box that was offered to the scientific community for less than 10,000 US dollars is a huge breakthrough. The ability to be able to leverage the Ditson sonar, which was previously a military-only piece of technology, to bring back visuals, meaning video, in an acoustic technology and have colorized images of predator-prey behavior is something else that was transmitted from military to civilian uses, and now is used in advanced echolocation and echo imaging that is much closer to 30 frames a second video than what we see on boats today. So those are just a couple of little tidbits. We are also working with various partnerships such as NOAA, as Brian had mentioned earlier, and space agencies, which will shortly be announced in the next few months. We have a lot of partnerships that unfortunately we can't talk about right now specifically, but they are integral in the answer that we're addressing right now in this question. But being able to look at technology, being able to look at perfecting and are of primary importance in the infrastructure of Proteus and its ancillary support ecosystems.
I think the technology only gets us part way. I think that's something we've really learned the hard way, and a lot of times. I work in climate adaptation, and we can develop all sorts of amazing tools and toys, but unless we get buy-in, unless we co-create it with the end users, it's never going to get used. And so I think a huge piece of this is looking at how we build partnerships to co-develop solutions, how we look at things like, for example, human-robot interactions. So we can build a fantastic robot, but it's the interaction between humans and robots that really matters. We have cognitive psychologists on our group who are looking at perceptions of nature and of the ocean. And so I think it's this holistic approach that it lets us not only develop new technology, but really work with people to figure out how will it be used for societal good. That's really key.
Thank you for the presentation. It was great. I think I saw both of your talks separately multiple times at multiple venues, so it's great to see you together. So my first question is towards that, and I think I'm going to throw some gasoline in the fire here. Is it a race? Are you racing to try to see who deploys that first, or are you collaborating? I think that's the first question. So the second question is, I'm one of the few scientists, rebreather divers out there, and there's many different reasons for that. There's a lot of scientists that want to do it, but there's definitely a lot of difficulties. There's a lot of training. There's a lot of investment in the equipment. Universities in general are averse to risk. And both of you plan to use rebreathers for the scientists to access the environment. How do you plan on jumping that hurdle, the training for the scientists?
That's a lot of questions in one.
Quickly start with the so Luis and I met at a Gordon conference on the mesophotic zone, and it's because our first site in Curacao is adjacent to a very deep slope where there's a healthy, thriving mesophotic coral reef and photic coral reef, and so looking at the connections between the deeper reef and the shallower are really critical. I mean, Fabien can give the official answer. I don't see this as a race as much as there's a huge, huge need for this. And if we had 10 more companies doing this, we still wouldn't, quote unquote, saturate the market. I mean, there's an enormous need for this. So I think we're going to learn from each other. I think there's a lot of synergy here to explore. So that's my view.
Yeah, totally agree.
Yeah, let me disagree with Brian on one thing.
I go 2-1. Yeah.
Yeah, so.
We do this all the time as an exercise in-house.
Sure.
It's disagree in the form of agreeing. But I disagree that it's not a race. But the race isn't amongst the Deep and Proteus. As a matter of fact, my CEO, Lisa Maricina, reached out, I believe, to Deep, or Deep reached out to us, and we have subsequent discussions, I think, or certainly welcome them, follow-up conversations to be had, because the cooperative agreements, such as the one proposed, can only benefit the ocean, can only benefit humanity. And as we move forward in this very trepidatious and very ambitious endeavor of building these underwater ecosystems to house human beings, to learn more about our life support system, we can learn from each other and in cooperative agreements that better all platforms and all sorts of underwater research. And the reason why I say I disagree with Brian is it's a race, and we should throw gas on the fire, as our host had said. But the gas on the fire that we're talking about isn't competition, so to speak. And to Brian's point, we could have 10 more of these organizations building these underwater habitats of various ilk and various purposes and still not saturate the market. The gasoline on the fire is about the fact that we are losing precious time. The first underwater habitat, Conch Shelf 1, was built in 1962. We're still putzing around, talking about climate change, talking about the overconsumption of natural resources, talking about climate change destroying our children's future. We are screwing around, and it drives, as you can see, I'm getting passionate. It drives me crazy that since the 1960s, experts, including people like my grandfather and his team, have been talking about these threats to humanity and to this little oasis in space, and we have been screwing around and wasting time. There is no more time. So the gas on the fire is to try and light a fire under our asses to get moving. And that's where the urgency is. The urgency is for us to get in the ocean. I'm all for space exploration, but why is it that in the United States, for example, the richest country in the world, are we spending 100 times more, 1,000 times more in space exploration and colonization rather than ocean exploration and colonization, so that we can learn more about our aquatic ecosystem, more about our life support system, and be able to make better decisions more quickly so that we can address the things that are actually in front of us. So these cooperative agreements, this push to in urgency to develop these kinds of systems, whether it be rebreathers, whether it be the ability to train the average human being to saturation dive in open circuit, to be able to reach those answers and that data, is paramount to the endeavors that we're talking about at this panel. It's not about fighting with each other. It's not about throwing gas on that. We don't have time to screw around. We are in serious jeopardy. And we're never going to send 7.8 billion people to Mars or Europa or another colony in outer space in the time that we have left to make better decisions. That's my answer. Sorry, I went on a little bit long.
Phil, would you like to comment too, please?
With the training side of things. So basically, before I worked at Deep, a lot of my job over the last 10 years was training specifically scientists to do a goal. So a university would come to me and say, we want to do this project in this depth, and the project is this. And then we'd basically design an educational system to get all the scientists ready to do that dive over a period of time that suited. But then on top of that, we created what we called the Guardian system, where basically anytime a scientist was working in deeper water on complex equipment, they were diving with a pro that effectively buddied them, but in a much more professional level. And we've managed to achieve this in 50, 60, 70, 80, and then Timmy Gambon from Heritage Malta has taken that on to 100, 110, mostly in archaeological work, but also in veteran recovery work for the DPAA. And it's worked with a zero incident scenario where you've got scientists who a year ago wouldn't have been capable of that site, and we design a training system to put them there with the right equipment for the job. As Fabien says, they're just tools. And then basically what happens, because you've got to do your research, you go a year later, you haven't been able to put the time in the water that maybe someone who dives just for fun is. So we go, right, next project is this. So we go 1 week, 2 weeks prior to the project and do a refresh, crash course training, get them back to spec. But then again, they're never alone or never just two scientists together, they're guardianed. And so when we created the Aquan network, which is very similar to the training that PROTEUS are going to do with their private aquanaut, we designed it so that anyone in this room, whether they're a sat diver, a scientific diver, an open circuit diver, a rebreather diver, can be slotted into that whole syllabus and taken to the level they need to be for the project that they've asked us to deliver.
Hello. Okay. Good morning. Thank you for the presentations. It's really amazing what you are doing. So, as a roboticist, I have a lot of questions, but I would like to ask you two short things. So, in terms of energy and communications, do you intend to the system to be autonomous in terms of dependency? So you won't depend from land. You want to get the energy from wind energy or wave energy or whatever. And in terms of communication, you also want to do it as a standalone, so you are not depending from cable systems or things like that. Because in the other hand, if you have enough power and a good communication system, you could improve your habitat to have data centers and things that need maintenance, that in our days they are already doing data centers in underwater because of all the problems of getting attacked and heating and so on. So this is a very good opportunity to have this kind of systems, but then you'll be vulnerable to attacks and things like that. So I would like to know your thoughts about it. Thank you.
It doesn't require a surface feed for power. So the power module would be lowered to seabed next to the Sentinel, as many as required for the number of nodes that were deployed. And it would be fully independent for the duration of the mission. Our mission durations are planned to be 28 days. It would then be recovered to surface, replaced for the next mission. We also are intending to use green energy sources from the ocean to supplement that. We will have surface feed to give high-level communications, Wi-Fi, for example, for research to continue. But that level of connectivity will not be required for safety, so if that surface tether were lost during a mission, they will still be able to maintain contact with the forward operating base. But the aim is for the Sentinel to be completely autonomous seabed, no surface connect for its primary needs.
Fabien, you want to go? You want me to go?
Sure. Yeah, I'm sorry. The connection started fading out there, so I didn't hear all of the question. But I heard about power systems, and without violating some of our NDAs and partnerships, what I can say is this: we have primary, secondary, and tertiary systems for three things. For three main systems. One of them is power. The other one is life support generation, the air or the gas mix that we're generating, depending on what depth we're talking about. And then, of course, the communication system. They're all based on redundancies, as was mentioned before, and they're based on the future technologies that are coming up. Let me give you an example. As part of the system to have a robustness and a dependability, there will be a cabling system from land to the habitat, depending on the environmental parameters working in what I can, which is a very advanced location for us, is Curacao. Curacao, because of its proximity to land, is conducive for both economic and safety reasons to have a power, water, life support generation, and communications that is cabled from land. Now, that's a primary system that's based on renewables, wind and solar. Those are peak energies, which in an island nation, along with the traditional systems there, are not always reliable. So we have a secondary system which is on board, which generates the same amount of power and about twice as much as will be needed in peak demand on the underwater community, and a tertiary system, which is an energy storage system, which will be leveraging things like saltwater batteries and such. Saltwater batteries are not a new technology, but they're one that's been overlooked. Now, why saltwater batteries? Why are our primary systems, for example, depending on the parameters, geographical parameters that are available? We're looking at installing OTEC, for example, which is an ocean thermal energy conversion. We're looking at the factor into the answer that you're seeking. So we take things very seriously in terms of not only the exercise of research, of long-term deployment, of installing an underwater habitat in an ecologically sensitive area. That's in the end of the day, we don't want to destroy what we're trying to study, but also depending on the depths, depending on the topography, depending on a lot of things, the engineers, as you may very well know, since you're an engineer, are looking at not a silver bullet answer, but one for each one of the locations that we have lined up. So we have, as mentioned, we have 30 systems for all of those things. Now, the data, the sensitivity to hacking, all those things that you mentioned before, the communications. As you may have experienced, the air-water interface and the density of water versus density of air is always an interesting thing to broach. We have technologies that now can broach that for flow communications, both for audiovisual and data transmission. Security and safety is obviously paramount importance, so PROTEUS will be independent, meaning untethered, for the sensitive kinds of systems so that we can answer the hacking issue. Number two, there will be a line of communication, a separate infrastructure, if you will, for communications so that we have flawless 1,000 gigabyte transmission capable of multi-threading 16K broadcast capabilities. So in terms of communications, which is also part of the safety system, but mainly part of the live communication system, we are very aware and concerned with making sure that all those systems are safe, secure, and of the highest technological capabilities. And ROVs, ROVs, AUVs, yes, deployed not from the surface necessarily, but from the habitat itself, so that when we have bad weather days, which depending on where you are in the world can be often. In my experience, over the 50 plus years that I've been on expeditions, you can count one out of every 3 days as a scrub day because of weather. Underwater communities have to worry about this a lot less. And so the deployment of those tools, that human technological interface will not be as affected by weather issues or communications issues, for that matter, being able to communicate with those tools and have them have kind of a homing device, so to speak, in case of a disconnect of some sort or a technological failure. Anyway, I can go on and on and on, and I'm sorry, I get passionate about these things, and now that I've had my coffee, 5